Okay. All right, so taking a look at the top, so we're covering derivatives and then tables. So what is the chain rule? You know it. So d dx of a function of u. Okay, remember, you take the derivative of the outside function first. So f would go to f prime. And then your u stays the same, and then you multiply by u prime behind that. And then remember that u prime would be basically like whatever the derivative of the middle is. Okay, next one, product rule. Derivative of d dx u times v. Remember, you do u v prime plus v u prime. Okay. Your log rule, the derivative d dx of ln u. Okay, remember ln x, the derivative is 1 over x. So ln u, the derivative would be 1 over u and then times by u prime. And then do y'all remember how we can condense that? What would we call that instead? U prime over u. And that's the one that I like better because then it's just like one big fraction instead of a fraction times something else. Okay, then exponentials, derivative of e to the u, what would that be? Times. If you have a u, you'd have to multiply by u prime. And then remember, a lot of times they'll put the u prime in the front, but overall it really doesn't matter. Okay, then last one is quotient rule. So if you take the derivative of u over v, remember that it's ho d high minus high d ho. So ho would be v u prime minus high d ho would be u v prime. And then over ho squared would be v squared. So usually I don't use that particular version of it, but it's the same thing. Okay, and we'll write out the other way when we get to a question like that. Okay, so when you're ready, take a look at the first one. Okay, what do we want here if we want d cubed, dy cubed? And how many times? 3 times, yeah? So if this is my f, derivative would be f prime. And then we have cosine 2x. Remember, it's snow cone, snow cone. So I'd go to negative sine 2x stays the same, but then times 2. And then I'm just going to put the 2 in the front. Okay, but we know that that is our u prime from taking the derivative of 2x. Okay, what would the second derivative be? So now we're at negative sine, so it'd go to negative cosine 2x. But then I'd have to times by another 2, and I already had a 2, so it's a what now? Okay, then one after that, we have f triple prime. This will be our answer. Derivative of negative cosine, what would that go to? And negative cosine would go to positive, yep. Cosine 2x, and then times by another 2 would give us an 8 in the front. All good on that? All right, take a look at the next one. Okay, we have 2 cosine x over 2. We want d squared y dx squared. How many derivatives are we taking? 2. One other thing here, I would rewrite this as 2 cosine. What is x over 2 the same as? So I'm going to think of that as half x. Just because then it doesn't look like I need a quotient rule. It's like, oh, I just have a number in front of an x. So derivative once, what would it be? So negative 2 sine half x. But then what's the derivative of the half x? Times an extra half. And so then what would happen in the front?
Just 1 half.
Yeah, it's... Well, half of 1 would just be 2. Yeah, perfect. So I'm going to rewrite my y prime is negative sine of a half x. And then from there, what would the second derivative be? Take the derivative one more time. Okay, so negative sine would go to negative cosine.
1 half.
And then put an extra half in the front. Exactly right. Okay, and then typically remember, if this is y prime, we want to label that, even though it's multiple choice, so that'd go to y double prime, which means we would want answer choice E. Yep. Good on that?
Yep.
Any questions? All right.
Wait, which rule is it?
That's chain rule. Because it's, think about, you have like chains of like they're inside each other, you know? All right, next one, we want a fourth derivative. Okay, and then this time they're giving you a number to plug in. So look, it says we want the fourth derivative of f at 0. So we're going to take the fourth derivative, then plug it in. All right, so here's f. What's f prime? So my 4 comes down to the front. What's my new power now? So 2x plus 1 to the third. Is that right?
No.
Chain rule, what's the derivative of the middle?
Oh, you want to do it like 2.
We'll have to multiply by an extra 2. So it would be 2x plus 1 is times 2, which means how could I rewrite that? 8, and then 2x plus 1 to the third. All right, now we're taking the second derivative. Okay, I'm going to use this version just because I think it looks better. So 3 times 8 in the front is what? 24. And then I'm going to power it down, so it'd be 2x plus 1 to the second power. But then chain rule says what? Times by 2, which means really that's a 48, 2x plus 1 squared. Okay, next derivative, we're going to the third derivative. So I do 2 times 48, what would I get? 96. This is the stupidest thing I've ever seen. Okay, so that's 98. My 2x plus 1 is to the first power now, but then times by what? Another 2. And what's my number in the front now? 96 times 2 would be... Yes. There we go. And then we need to take one more derivative. Just follow your rules. Remember, this is to the first power. So if I do 1 times 192, what would I get? Okay, 192. And then what's going to happen to my 2x plus 1 if I power that down? It'd be to the 0, and anything to the 0 is 1. That's right. And then times by the derivative of 2x plus 1, which would be an extra 2. And then remember, like you just said, anything to the 0, you don't even have to put, that's really just a 1. So then 2 times 192 would be 384. And so you'll notice they might give you a little bit of big numbers, but they're not going to give you anything so big that, you know, you'd have to do like long multiplication. But you could if you needed to. Okay, next one. Let's jump down to this one, and then we'll come back to this. Okay, so next one, on the bottom here, we want the derivative at 0. Okay, well then, how do we take the derivative of this? Think about the one we just did. Okay, bring it down, and then what? And then reduce the power by? By 3/3. Very good. So this is normal power rule, but we're going to have to do a chain rule with it. Okay, so my 2/3 is going to come down to the front. The core stays the same, x squared minus 2x minus 1. But then if I do 2/3 minus 3/3, because that's the same as minus 1, what's my new power? Negative 1/3, and then times by what?
2x.
Yes?
Yeah.
Yes. 2x minus 2. So remember, if this is your u, then you have to multiply by whatever the u prime is behind it. You good? Okay, and then from there, what I would do before I plug into this is I would make this a fraction, all like one big fraction. So let the 2 be the top leader, let the 3 be the bottom leader, and then the remaining terms, which one should go into the bottom? Which of these?
Oh, the first one.
Yeah, because this one has a negative exponent, and if it's a third power, what type of root is that? Good. So I'm going to do cubic root of x squared minus 2x minus 1. And then 2x minus 2 is just chilling. I'm just going to put that on the top. Okay, so remember, negative powers need to go into the denominator, but the positive power you just leave on top. Okay, then from there, what are we plugging in? This is at any x that I want. Okay, I want it at 0. Very good. So then I would do f prime of 0 equals 2 times, well, this is 2 times 0 is
0.
minus 2 is just negative 2. And then on bottom, I have my 3 in the front, cubic root. And then this is 0 minus 1. Can you take the cubic root of a negative?
Yeah.
Yes. What can you not take?
Square.
Can't square root, but you can cubic root. What's the cubic root of negative 1?
Negative 1.
So I have 2 times negative 2 is negative 4 on top. 3 times negative 1 is negative 3 on bottom, which is going to reduce to 4/3. Okay.
Square root negative 1 because it will be imaginary number?
It would be imaginary. And you're only working with real numbers for the AP test. So that's why you don't have to worry about any.
How did you get to -4 over -3? I just missed that.
That's okay. So I did 2 times negative 2, and I got the negative 4. And then the cubic root of negative 1 is negative 1, but then I multiplied it with the 3. And then from there, if they're both negative, then we can cancel them out. All good with that? Okay, middle question. So we've done a billion examples of chain rule. What is the middle question asking you to do? Which rule? This one right here. Product rule. Very good. And remember, for product rule, you're going to break it down into the pieces of the product. So what would my U be? The first part of the product here. X minus 1. And then the second part would be the x squared plus 2 cubed. So my U is an x minus 1. My V is an x squared plus 2 cubed. So remember, after we write our U and V, now we're going to take the derivative. What's the derivative of U?
Just 1.
1. And then in the derivative of V, what rule am I going to have to do? Chain rule, because it's all of this crap cubed. So my 3 is going to come down to the front. What's the new power now? Okay, to the 2. And then what do I have to times by at the end because of chain rule? 2x. Which means really the 3x and the 3 and the 2x could be a what? So 3 and 2x is really just 6x, and then x squared plus 2 squared. So kind of weird there, but we can do a little bit of work on that to make it a little bit easier, okay? All right, then from there, I don't know if that made it better. Okay, then from there, we're gonna do our product rule. So it'll be this times this plus this times this. So if this is f, derivative is f prime. So it'll be 1 times x squared plus 2 cubed, plus in the middle for product rule. And then x minus 1 times 6x, x squared plus 2 squared. Okay, look at that. Look at your answers. What do we still need to do? Probably. Because we've done everything right, but...
Cancel out maybe the x squared plus 2.
Okay, so when you say cancel out, you mean factor amount, yeah? Because if they have a GCF, we can pull that out to the front. So I'm going to do my x squared plus 2 as a GCF to the front. How many of them can I bring out? Twice. So then what's going to be left over? Remember, it's a total of 2 terms here. You have 1 term here and then 1 term here. So what's left over from the first term?
X squared plus 2.
One of the x squared plus 2's. And then what's left over from the second one? And
6x.
the 6x. Very good. So when I pull this out, I still have the x minus 1 and the 6x. And then what I'm going to do on that is I'm just going to reorder it. Because when I clean this parentheses up a little bit, what am I going to have to do here first? Yeah, just multiply it in. So 6x times x is,
6x squared.
so I have x squared plus 2 plus, and then that'd be 6x squared and then 6x times minus 1 would be minus 6x. And then I would look and see which of those can go together. So we have an x squared and a 6x squared makes 7x squared, and then minus 6x, and then plus 2. Okay, and so this reduced down to that, but then remember, what did I have in front of that before I did all this crap?
X squared plus
Yeah, so then which answer would we want? D, yep. Very good. All right, turn the page. Doing great. All right, next one. Take a look. ln u, what was the rule for the derivative? 1 over u and then what?
Over U prime.
So u prime over u. So I'm going to just use that rule because I think it looks easier, but it's the same thing. So we have ln of u, this is our u, and then we want to take f prime of that and then plug in 0. So what's the derivative going to be if this is our u? Well, we're going to keep the exact same u on the bottom. So it would be x plus 4 plus e to the negative 3x. But then what would we put on top? It's u on bottom and u prime on top.
E to the negative 3x.
1 plus e to the negative 3x times what? Times negative 3. Yeah, because remember, if it's an e to the u, you have to multiply your u prime down to the front. Okay? And then from there, that's f prime for whatever number I want. Now I want f prime at 0. Exactly right. So I'm going to have 1 minus, because I don't want to have a plus and negative 3. So 1 minus 3 e to the negative 3 times 0. What's e to the 0? So just cross that out. Now keep the minus 3, because the minus 3 has a 1 behind it, but the 3 would stay. And then on bottom I have 0 plus 4 plus e to the negative 3 times 0. What's e to the negative 3 times 0? 1. And remember, you need to keep the 1 in the front so that you remember to add it with a 4. Okay, otherwise you'd be probably picking the wrong answer. Okay, so then on the top I have 1 minus 3. On bottom I have 0 plus 4 plus 1, which means final answer would be negative 2 over 5. Answer A. Very good. Okay. All right. Take a look at the next one. Okay, how many layers does the next one have? So normally it has 2. This one has 3. So you have your sign on the outside. Okay, what's inside sign? Okay, you have ln, and then what's inside ln? Okay, the 2x. Very good. We have 3 colors. Okay, so then remember, you just go 1 layer at a time. So first we want to do sine. What's the derivative of sine? Cosine. What happens to the middle? Stays the same. And now I want to take the derivative of ln 2x. Well, then what's the derivative of ln 2x? Here's my u. And then what do I do? U prime over u. What's my u prime?
2.
Just a 2 over 2x. And then inside the ln, it was a 2x. What's the derivative of 2x? An extra times 2. Okay? And then from there, what are we looking for here? Let's see. 2. So we know we want a cosine, so that one's out, that one's out. And then out of the 2 that are left, we should have another 2. Oh, wait, hold on. One thing here. When you take the derivative of the ln, okay, technically, what was the derivative of the 2x? It was already the 2, so we have an extra 2 here. Sorry. And so then from there, what would happen with the 2 top and bottom? Whoosh. So then you would just end up with this one. Okay? All right.
Do the extra one for 2x?
You don't. And the reason why is because your ln function already has the u prime in it. So we're already doing chain rule on that when we did the u prime over u. Okay? All right, so take a look at the next one. We haven't done this in a long time. Okay, what does this mean though? The little negative one.
Inverse.
Yay, inverses. Okay, so I want you to make a little inverse chart. Okay, we're gonna put f of x on one side, we're gonna put g of x on the other side. They're each other's inverses. Now, they're asking me for g prime of 3. So that means that 3 is the x value, and I want the slope at that point. Okay, think about if that makes sense so far. Okay, I know f and g are inverses because of this statement right here. I want g prime of 3. Then that means at the point where 3 is the x, I'm going to find the slope. Okay, what is the relationship between the ordered pairs for inverses? Do you remember? We haven't done this in a super long time. The x and the y's are just reversed. So if this is 3 comma something, then this one is something comma 3. Now, look at the information they gave you. They told me some stuff about f. They told me f of 3 is 15 and f of 6 is 3. Then which of those do I want? For f, I want the x value to be a 6. So I'm going to use this one. They gave you the other one for nothing. You don't need it. Okay? So if f is 6 comma 3, then its inverse would be 3 comma 6. Okay, the other new relationship that you should have already known this from pre-cal, but for my class is that their slopes are reciprocals of each other. So if I want to know the slope on this side, then I need to know f prime of 6. And did they give me f prime of 6?
Yeah.
What is it? -2. Then I know that the slope on the other side will just be that flipped this way, like a reciprocal. So it would go to, well, but you have to flip it, so it'd be 1/2. Okay, so there's a unique relationship with inverses that if the x's and y's are switched for the inverses, then the slopes are just reciprocals of each other.
And so does the negative stay?
The negative stays. When you change the sign and flip it, that's for perpendicular, which is also a thing, but you shouldn't have to do that on the AP test at all. So you're literally just flipping it.
So for the point, we just reverse it, while for the slope, we flip it.
Yep. So basically, they're giving you all the information about f, but then they're asking you stuff about g. So that's where you just have to remember that if I want g prime of 3, then I know 3 is the x value for g, then it has to be the y value for f. And then from there, I find the slope for f, and then I just flip it back for g. And that relationship is always true whenever you have inverses. Okay? All right, turn the page. All right, let's see. Ooh, we just did inverse tan. Do you guys remember the formula for that? That was the one where it was this. It was 1 over a squared plus u squared. Do you remember that? And then it went to 1 over a inverse tan u over a. We did this right before spring break.
That makes sense.
Okay, but it's fine. Basically, all that you would do is you would say, oh, this is the inverse tan formula. We learned it the integral direction. Well, then the derivative direction, you're just doing the opposite.
And do we have to memorize this for our...
You do, but remember, you have that formula chart all the way up until the AP test. So if I were you, I would just keep the formula chart out and then like a couple days before the test, just practice the ones that we've been starring. Okay? All right, but general prediction, that probably won't be on the AP test, so let's go to the next one. Okay, equation of a tangent line, how do we do it?
Oh, we need a slope, the point.
Yes, and we already have the point right here, so then all we need is the slope, which means we're doing what? So we have the point, we need the slope, then we need to take what? The derivative, very good. And what rule are we going to need to take the derivative of that? Product, quotient, chain. That would be product, very good. So my u is going to be what? X. My v is going to be what?
1 minus 2x cubed.
To the third, and then we're just going to take the derivative of that and then plug in our point to know the slope. So u prime of x would just be what? V prime, yep, would be?
3.
Yes.
1 minus 2x.
Yes. To the
Times
2, and then times by
2.
negative 2, right? Yep. And then from there, if you want, you can be like, oh, the 3 and the negative 2, let me put that together and turn it into a negative 6. Okay, that step isn't really necessary, but you could do it. Okay, then from there, we're doing our product rule. So if this is f, the derivative would be f prime. And then it would be this diagonal plus that diagonal. Order doesn't matter as long as you hit both of them. So 1 times 2 minus whatever it is just going to be that. You don't even have to put the 1 unless you just super want to. Okay, and then my other one was x times negative 6, 1 minus 2x squared. And then what x value are we plugging in for our slope? This is the slope anywhere. We want the slope at our point, which is 1, negative 1. Then what are we plugging in? The 1, the x, yeah? So we just take that and pop it in right here. So let's do it. What is 2 times 1? What is 1 minus 2 then? And then what's negative 1 cubed? Does it keep the negative or turn positive? Stays negative. Okay, then plus this 1 out here we can just ignore. Okay, in here I have another 1 minus 2, which is negative 1, but then I'm going to square it. Positive 1 times negative 6 is negative 6, which means my slope comes out to be,
Why are we ignoring that x?
so this x right here, because you're plugging in a 1. So think about, yeah, even if you get a negative 6 in here, when you times it by 1, it would just stay a negative 6. So then my slope is going to be negative 7, which means, which answer choice, yeah, can we pick already without even doing it? It's got to be A. Okay, now how would you get there? Let's just review, since that's kind of the point of this, is you would do y minus negative 1 equals m, which is negative 7, and then x minus 1. And then notice, sometimes they'll put the multiple choices in this order, but if they don't, then you just solve it. So what's negative 7 times x? Okay, so I have y plus 1 equals negative 7x. Then negative 7 times negative 1 is plus 7, and then minus the 1 across. So that's how they're getting that 6 for your y-intercept. Yeah? Okay. All right, I'll pick one more and then we'll be done. The last one. Which one should I pick? Wow, we didn't get through very much. That's okay, though. Okay, I picked this one. Let's do 8. Okay, so remember, if your x's and y's are all jumbled together, when you take the derivative, anything that has a y in it, you're going to put a what at the end? Do you remember? dy dx. So if I'm doing this one, okay, what's the derivative of 2y? 2 dy dx. Okay, plus, what about 4 cosine y? What's the derivative of that?
4 sine. Negative sine.
So negative 4 sine y, then what?
dy.
dy dx. Okay, equal to x plus 2. What do I get on the other side? Just a 1. What about the plus 2? It's a constant, so derivative is 0. Okay, then all my y stuff is already together. Do you remember how you factor the dy dx out? So it'd be dy dx, parentheses. What's left over when I take those out? 2 minus what? 4 sine y. And then how do I get the dy dx by itself? I put it on the, you just divide over it, yeah. So it'd be 2 minus 4 sine y, and then 2 minus 4 sine y. And now you have your dy dx.
Why is it not 2y dy dx? While like for that other one.
Are you talking about for this one?
Yeah.
Because remember, when you take the derivative, it's a y to the 1. So then you do 1 times 2 is 2, and then y drops down a power to go to y to the 0.
Oh, we don't care about sign, right? Sign would just be.
Yeah, you're doing the snow cone. Okay, then if you want a vertical tangent, what do you set equal to 0 in the slope?
1.
Okay, which part of the fraction? If you want it to be vertical.
The bottom.
The bottom. Because what type of slope is vertical? Starts with a U. Yes. So you set the denominator equal to 0. What if they wanted it to be horizontal? Then instead of the bottom equal to 0, you'd set the top equal to 0. So I'm going to do 2 minus 4 sine y equals 0. Then add that 4 sine y across. Now it's 2 equals 4 sine y. Then what next? Divide by 4. What's 2 over 4 the same as? 1/2. And when is the sine of y going to be a half? For what angle? Think about the unit circle. We want 1 finger above.
30.
Well, it'd be
40.
0, 30, 45. Oh, wait, why am I doing degrees? Sorry.
Yeah.
Pi thirds. So y would be pi thirds. Okay, and then look what it says. Find values of y. So we found y values of y. We're good. Okay, if it asked you for the complete point, though, remember you'd have to go back to the original. Okay, last thing it says is to write an equation of the tangent line, which we already did. Tangent line, what would you need? What 2 things? How do you find the point if it's the x-intercept? What would you let be 0? What'd you say?
I don't know.
So if think about if you're on the x-axis, your y has to be a 0. Otherwise, you wouldn't be on the x-axis. So now think about if I go back to the original, it was 2y plus 4 cosine y. Well, then it's 2, 0 plus 4 cosine 0 equals x plus 2. So remember, for an x-intercept, you're zeroing out the other letter and then solving. What's 2 times 0? What's cosine 0? Be careful here. 1, which means this doesn't cross out. It goes to a 4. So then what do I do with my plus 2 over here? Subtract the 2 across. Which means what's my point? My x value is,
2.2.
so it'd be 2 comma 0. And then what additional thing would I need after I find the x-intercept, which is my point? Then I would need my slope. And look at your slopes right here. All I have to do is plug it in. Remember, it's dy dx, vertical line, 2, 0. And then we're just plugging in. So it'd be 1 over 2 minus 4 times the sine of 0. What's the sine of 0? 0. So really, I just have 1 over 2. And then from there, write your tangent line. So it'd be y minus 0, half for the slope, x minus 2. All good? Coming back a little bit. Are you taking the AP test?
Yeah.
You taking it? You're all taking it? Are you taking it? Bryce, are you taking it? Yes. All right, I'll sign y'all sheets. Does anybody need a new sheet?